today we're talking about empirical formula. So we're going to start with some definitions. Molecular formula is the chemical formula that indicates the actual numbers and types of atoms in a molecule. This is different from the empirical formula, which is the chemical formula that gives only the relative number of atoms of each type of molecule. Sometimes the molecular formula and the empirical formula are different, as in the case of something like hydrogen peroxide. The molecular formula here is H2O2, while the empirical formula is HO. The simplified version is HO. Sometimes the molecular formula and the empirical formula are the same, in the case of carbon dioxide, which is CO2. Here you can see the empirical formula and molecular formula are the same. So, how do we find empirical formula? Generally, when you work an empirical formula problem, you will be given the mass percentage of elements out of 100. So you can assume that you're using 100 grams of a sample. From that 100 grams, you take each percent and convert to grams to each element. Then you find molar mass, convert to moles of each element, calculate the mole ratio, and you end up with your empirical formula. So there's an easy little chant or cheer that you can use to remember how you find empirical formula. And it goes like this. Percent to mass, mass to mole, divide by small, multiply till whole. So if you can remember this little series, then you will always be able to work empirical formula problems. Okay, so that said, let's work a problem. Give the empirical formula of the following if a sample contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. You can see right off the bat that these percentages will add up to 100. So you can easily go from percent to mass. 40% carbon, 40 grams of carbon. 6.7% hydrogen, 6.7 grams of hydrogen. 53.3% oxygen, 53.3 grams of oxygen. Okay, step 2, mass to mole. First step in this part is to identify the molar masses of carbon, hydrogen, and oxygen. So here you can see my lovely periodic table interpretations. So first you would find carbon, hydrogen, and oxygen on the periodic table. Because we know how to read a periodic table, we can find the molar masses of each of these elements, which are given below the symbol for the element. So carbon's molar mass is 12.01, hydrogen's 1.01, and oxygen's is 16. From there we use dimensional analysis to find the number of moles of each element. So 40 grams multiplied by 1 mole is 12.01 grams, gives us 3.3 moles of carbon. We have 6.7 grams of hydrogen multiplied by 1.01 grams per mole, and that gives us 6.6 moles of hydrogen. And finally, we have 53.3 grams of oxygen and 16 grams per mole of oxygen, which gives us 3.3 moles of oxygen. So step 3, divide by small. So from the 3 molar amounts here of carbon, hydrogen, and oxygen, we identify that 3.3 moles is the smallest number that we found. So you divide each molar amount of element by that number. So 3.3 divided by 3.3 is 1. 6.6 divided by 3.3 is 2. 3.3 divided by 3.3 is 1. The final step is multiply till whole. This step you don't actually have to do in this example, but per se, you ended up with a number here that was not whole, like 1.5. To find empirical formula, you would have to multiply all numbers until you were left with whole number coefficients. So in this example, the empirical formula would be CH2O. And you can see where we get those numbers: 1 carbon, 2 hydrogens, and 1 oxygen. So finally, we can use the empirical formula to find molecular formula. Let's say the experimental molar mass is 91 grams per mole. First, you find the molar mass of your empirical formula, which we found previously was CH2O. Using the molar masses, you can find the mass of the empirical formula. 12.01 carbon, we have 2 hydrogens times 1.01 and 16 for oxygen, which gives us a total mass of 30.03 grams per mole. So you divide the experimental mass by the empirical mass. So the experimental mass is 91, and you divide by the empirical mass, which is 30.3, and you end up with 3. So you multiply the empirical formula by the whole number found in part 2, which is 3. So the empirical formula CH2O multiplied by 3 gives you C3H6O3.